Hey guys, lesson 1.3 for Math 8, page 23. Grab your calculator. We are going to be multiplying and dividing monomials. I've got to make it short and sweet today. All right, so real world link, we're talking about spiders and how their size relates to the millimeter. Spiders in North America can range in size from 1 millimeter in length to 7.6 millimeters in length. We're going to fill in this table and look at how exponents are involved. 1 millimeter would be represented as 1. And when you write it as a power, you would write 10 to the 0 power. Let's look at centimeter. Is 1 times 10 times longer than a millimeter, which would be 10. Exponent would be written as 10 to the first power. A decimeter is 10 times 10 times longer, which is 100. There's far. That's written this way, 10 to the first times 10 to the first, which is 10 to the second power. Notice how 1 times 1, we get 2. We actually are adding the exponents. We're not doing any multiplying. All right, meter, 100 times 10 is 1,000. Represented with exponents would be 10 squared times 10 to the first. And again, this is 10 squared. This is 10 to the first. So this is represented as 10 to the third power. Let's keep filling in our table. Here we have 1,000 times 10 is 10,000. Represented with exponents, we're going to represent that as 10 to the fourth. 3 plus 1 is 4. Here we would have 100,000, because that's what this answer is, which is represented as 10 to the fifth. There's 5 zeros. I've added 4 plus 1. Here we would have 1 million. Oh man, those are big zeros. There we go. Represented with exponents, 10 to the fifth times 10 to the first is 10 to the sixth. So what can we say about when we're multiplying monomials? It says, look at the entries in the last column. What do you observe about the exponents of the factors and the exponent of the product? Well, you add them together. There we go. You add them. All right. A megameter is 100 million times 10, or 1 billion times longer than a millimeter. Extend the pattern to write this using powers. Well, I know that this is 10 to the 8th times 10 to the 1. 10, if it doesn't have an exponent, there's a 1 there, equals 10 to the 9th power. All right, let's look at this in depth. Product of powers. Here's your rule right here. To multiply powers with the same base, again, they have to have the same base, you add their exponents. If you look at this right here, 3 squared times 3 to the fourth, that's 3 times 3. And then this one would be 3 times 3 times 3 times 3. So we have 6 3's all together being multiplied. So that's represented with 3 to the 6th. So you literally can add this plus this to get that. Let's look. All right, simplify using law of exponents. My pen and stuff disappeared on the side, so I don't have to go back and forth. All right, 5 squared times 5. You're going to, the common base there is 5. Again, 5 with no exponent is 5 to the first power. All right, so you add the exponents. 2 plus 1 gives me 5 to the third power. If you want to check your work, you can always work backwards or work it out and see if you get the same thing. They've done so here. Number 2, c to the third times c to the fifth. Add those exponents. 3 plus 5 gives me 8. Okay, number 3, don't get scared even though there's coefficients. You're going to multiply the coefficients together as shown here. Negative 3 times 4. Coefficient is the number in front of the variable. Group the bases together, add the exponents, and multiply out the exponents. So negative 3 times 4 is negative 12. Add those exponents together and you get 7. So final answer is negative 12x to the 7th power. All right. If you want to give this a try, go for it. Actually, you don't have a choice. So pause the video, try it out. I'll give you the answers in just a second. All right, answers here. I will write in purple. 9 to the third times 9 squared is 9 to the fifth power. I added 3 plus 2. B, a to the third times a squared is a to the fifth power. I tried to make my a look different than my 9. All right, number C, we're going to multiply the coefficients and then multiply the base. The common base is m. Notice how I gave this m a 1 for its exponent. So we're going to have negative 16 m to the 6th power. 1 plus 5 is 6. So Oh, it's not negative. Oh my goodness, I almost kept going. It's positive. 16m to the 6th. Woo, caught my mistake before I finished. All right, let's keep going. Quotient of powers, guys. Now we are dividing. Guess what? You're going to do the opposite of what you do when you're multiplying. So when you multiply, you add the exponents. When you're dividing, you subtract. So underline that right there. Looking at this here, you can see 5 to the 7th has 7 5s. Divided by 5 to the 4th is 4 5s. If you cancel them out like they've done here, you're left with these 3 5s. So that is represented as 5 to the 3rd. Again, 7 minus 4 is 5. That's where I'm sorry, 7 minus 4 is 3. Wow, that's terrible. All right, so 5 to the 3rd. Let's keep going. All right, simplify using law of exponents. Let me get my selector and go. Common base here is 4. 4 to the 8th divided by 4 squared. Subtract the exponents, and you get 4 to the 6th power. I prefer that you leave it as a power. Number 5, n to the 9th divided by n to the 4th. Subtract the exponents, and you get n to the 5th power. Don't let this one freak you out. All you do is group the exponents, group the bases that are common together, as shown here. So they've rewritten this as several different groupings. They've grouped the 2's together, the 3's together, and the 5's together. Remember that this 5 has an exponent of 1. Divide it out, and you get 2 to the 3rd, 3 to the 1st, 5 to the 1st. All they've done is subtracted the exponents. Then they've simplified it out or solved, and we end up with 120. You're going to try it on your own. Would you go ahead and pause the video, try these, and I'll come at you with the answers in just a second. All right, answers here. D, you should have, I need to get my pen back out. You should have 5 to the 7th, 5 to the 4th would be 5 to the 3rd power. E would be x to the 10 minus 3 is 7. Number F, divide the coefficients. So you have 6w. Notice that there's a 1 here for you. I gave you a hint. 5 minus 1 is 4. Number G, 3 squared times 5 to the, remember there's an invisible 1 here, 5 to the 1st power. You don't need to write that power. But I'm going to just to show you. And then 7 to the 2nd power. H, you're going to have 5 squared times 7 to the 3rd times 8 to the 1st power, or just 8. And the last one, you're going to have -2, keep it in parentheses, to the 3rd power. It's okay if you didn't. Go ahead and add them on now if you did, if you didn't have them. 3 squared. Nope, that's a lie. 3 to the 3rd power, because this is a 1. So 3 to the 3rd power, and then 5 to the 3rd power. Awesome. All right, Hawaii's shoreline is about 2 to the 10th miles long. New Hampshire shoreline is about 2 to the 7th miles long. How many times longer is Hawaii's than New Hampshire's? Again, we're just taking a word problem and solving it out. So we're going to divide 2 to the 10th by 2 to the 7th, subtract those exponents, and you end up with 2 to the 3rd. Or if you multiply it out, 2 times 2 times 2 is 8. So it's 8 times longer. All right, guys, wow, we're done. I'll go in so we don't have this ugly page. All right, so what I want you to do, work on that guided practice that's on your page and come to class tomorrow, and we will start with guided practice and grading it. All right, see you on the flip side.